Hey everyone, and welcome to my video for quadratic formula. We are going to start, before we get into the new stuff and that crazy looking formula down there, we're going to start by doing a simplify radical problem. So we did this last week and introduced it to help you get your answers in the simplest form that look like this example right here. So we're going to simplify -2 plus or minus the square root of 40 over 6. Now there's a new thing probably in this example that you're like, what the heck does that mean? And that would probably be this plus or minus. That is part of our quadratic formula. And so I'm including it in this example so that we can get a little taste of it before we get into the whole thing. But we're going to go through, and just like we did last week in simplifying radicals, I'm going to start this problem by simplifying that square root. So the square root of 40, I'm going to do that over here to make sure we get all the steps for this one. The square root of 40, I want to think about what perfect squares go into 40, what perfect square factors go into 40. So I know for sure that 4, which is a perfect square, and 10 are two good factors. And really, those are the only two factors that have a perfect square. So it's got to be 4 and 10. So I am going to rewrite the square root of 40 as the square root of 4 times the square root of 10. So remember, we did this last week. It'll be in last week's module if you are completely blanking on this process. So then once we do that, we want to take our perfect square and actually square root it to get 2 square root 10. Now I'm going to go back over here and actually write that in my quotient over here. The last thing that we can do is that these coefficients, oh wow, did not mean for that to happen. Okay. These numbers over here, they can all be divided or simplified. And that's the last thing we have to do to fully simplify this problem. So I want to take -2 over 6. That would reduce to -1 over 3 plus or minus, and then 2 over 6 would be +1, and we leave the square root 10. So since they have that common factor, 2 and 6 can both be divided by 2. That's how we would simplify this problem. So that would be our final answer. Now the plus or minus means that one of our solutions for this quotient right here is going to be 1 plus the square root of 10 divided by 3. And the other solution is going to be, 1 minus the square root of 10 over 3. When we take the square root, I'm going to do another example over here. When I take the square root of 4, I know that means I multiplied something by itself to get 4. So that means I multiplied 2 times 2 to get 4. So that means 2 is the square root. The other possibility for a solution, though, is what if I multiplied -2 times -2? I still get +4, so I could still take the square root and get a negative. So that's kind of why we have that plus or minus that's built into our formula. The great part about the quadratic formula is that it's going to be in there for you. You don't have to remember that every time. So that's our little example for the first part. Now we're going to get right into the new stuff. So the standard form of a quadratic equation, and I kind of wrote in that area, so I'm going to write it down here, is ax squared plus bx plus c. So remember, a, b, and c are coefficients, and then we obviously have to have the x squared to be a quadratic function. The quadratic formula, if you look at that, it's x equals -b plus or minus the square root of b squared minus 4ac, and it's all over 2a. It's kind of a lot. If we were like in class, this would be on our formula charts. I'm just going to make sure it's on anything that you're doing, but you might want to write it down on like a sticky note or a note card just so you have it to work with all of the stuff that you're going to do in this module. The quadratic formula can be used to solve any quadratic equation. So anytime we see an ax squared plus bx plus c equal to 0, anytime we're told to solve a quadratic function, we could use the quadratic formula. That's super helpful if we have one that we maybe like can't factor into binomials. So we can even factor or solve using the quadratic formula, even if factoring into binomials isn't an option. So for example, if I had the quadratic equation x squared plus 5x plus 7, and I was supposed to solve that. If I tried to split this and solve it by factoring, if I think of the factors of 7, it's only 1 and 7, and they're supposed to add up to 5. That is not possible. 1 and 7 will never equal 5. So that means I cannot solve this one by factoring. So my other option would be I need to use the quadratic formula. The quadratic formula has this special little part in it called the discriminant. And I'm going to highlight it right here in this very pale color that you probably can't see. Awesome. The discriminant is the part under the square root. So it's the b squared minus 4ac. And that is going to tell us some specific things about the types of solutions that we're going to have. So just if I'm dealing just with a discriminant, there's some different indicators from the value that ends up being under the square root that will tell us specific things about our quadratic function that we're trying to solve. So if in this little chart, we're going to fill this in first. If my discriminant, b squared minus 4ac, is greater than 0, so that means if my discriminant, or whatever ends up under the square root, is positive in the quadratic formula, that is going to mean that we are going to have two real solutions, like two actual solutions that we can get. And on a graph, that means that we have a quadratic function that goes through the x-axis twice. Because remember, solutions are the same thing as x-intercepts. So it's going to have two solutions, which we know are x-intercepts, roots, zeros, all that stuff. If our discriminant is equal to 0, so if we solve or plug that stuff in and we get 0 as the discriminant, that is going to mean we only have one solution. So in a graph, it would look like our quadratic function just touches the x-axis one time. So we only have one x-intercept. So that's when the discriminant is 0. When the discriminant is less than 0 or negative, that's when we have problems. We are going to have 0 solutions. Now, in the future, you will learn about things called imaginary numbers. We do not have to talk about those yet. But you will have some solutions when the discriminant is negative that are called imaginary solutions. However, we are only going to deal with real solutions. So real solutions means like real actual numbers that exist, not imaginary. I know it sounds crazy. Worry about imaginary in the future. So all of these are your real solutions. There are some imaginary ones that happen when you have a negative discriminant, but again, we don't have to worry about that. The graph, when you have a negative discriminant, would be an example like this, where it does not cross the x-axis at all. So you have 0 solutions, and it does not cross the x-axis. So those are the things that the discriminant can tell us. There are some questions in your quizzes, practice assignment, and your quiz that will ask you specifically about the discriminant. So that's a good starting place. And you'll learn how we plug values in here in this next part where you could test the discriminant. So now we're going to jump right into plugging into the quadratic formula. And here you can see we kind of broke it down for you a little bit. So if you wanted to just say go for it and try it after we determine A, B, and C, I encourage you to do so. The first thing we're going to start doing is determining what A, B, and C are before we even attempt to plug in the values. So remember, A is the coefficient that's in front of your x squared. So for this example, it's a 1. I don't see a number there. That means it's 1 times x squared. Then B is -2. We want to make sure we include that negative sign on the 2, the coefficient for B. And then that means that C is -24. So once we do that, here we have the quadratic formula kind of broken down for us. I'm going to rewrite it so that you can see it right here. So we know exactly what we're plugging into where. So first we have negative B. Sometimes I like to think of negative B as the opposite of B. But negative B will do the same thing. Basically, it will change the sign of B. So since B is -2, we're going to have negative B, so -2. We'll simplify that later. Then in parentheses under my square root, I'm going to make sure I plug in B, which is -2, minus 4 times A is 1, times C, which is -24, and it's all over 2A, so 2 times 1. Now I know this looks crazy and kind of a lot, but we're going to take it step by step and simplify as much as we can. So the first thing I'm going to do, because I really don't want to forget it, is change -2 to be +2. A negative times a negative is positive. So that would be 2 plus or minus the square root. And I want to simplify the discriminant. So if you had a calculator, we could do this on a calculator and it would be no big deal. But since we don't, we're going to have to kind of work through this with mental math for the moment. So -2 squared would be +4. Remember to put the negative in parentheses, especially when you're squaring it. And then -4 times 1 times -24, that's actually going to give me a positive result, and that would be +96. And yes, I just paused that to multiply it, so you're definitely allowed to use a calculator. Then I have to remember it's all over 2 times A, so 2 times 1, which is 2. I'm going to keep simplifying. So now I have 2 plus or minus, and then I'm going to finish that square root is square root 100 over 2, and we're going to keep going. Don't do anything with your 2's yet, even though I'm sure you're tempted to do so. Now we're going to go and, 100 is a perfect square, so I know that I can simplify the square root of 100 to be 10. So I've got 2 plus or minus 10 over 2. And I can already tell there's going to be more steps to my simplifying. So I'm going to rewrite that over here. 2 plus or minus 10 over 2. since we are going to have two solutions, two real solutions for this one, I want to go through and I want to do 2 plus 10 divided by 2, and I also want to do 2 minus 10 divided by 2. When we simplify those, you would add your values at the top and get 12 divided by 2, which is 6. So you get one solution that's 6, and then 2 minus 10 is negative 8 over 2, which is negative 4. So we get two solutions here, 6 and negative 4. And when we did solving by factoring, I told you guys there's a lot of different ways you can write these answers. So you've got 6 and negative 4 as your two solutions, which would be your x-intercepts. Now we're going to go through and do the whole thing, and we're going to leave our answers in simplified radical form. So I'm just going to do these next few examples. I might leave one or two blank for y'all to practice on your own. Maybe just the last one. So I know this video is going to be kind of longer, but you might need it because this is new. So our next example, x squared plus 10x plus 12 equals 0. I'm going to write down my coefficients. So I know a is 1, b is 10, and c is 12. So remember a, b, c. A, B, C. Then I'm going to rewrite the quadratic formula again. So we've got it on this page. I'm going to start plugging in. So I want negative b. So I want to write negative 10 plus or minus the square root of b squared. So 10 squared minus 4 times 1 times 12 all over 2 times a, which is 2 times 1. Okay, so now we start to simplify. The first thing we want to do is get that discriminant simplified down. So if I do 10 squared, I know I'm going to get 100. And then I have negative 4 times 1 times 12. So I've got 100 minus 48, and that would give me 52 as my discriminant. And then I'm going to put it all over 2. Side note here, if I have a discriminant of 52, remember that means I can already start thinking about what kind of solutions I'm going to have. That means I should have 2 solutions. So I want to make sure that's what I have when I get done. Now we're going to simplify our radical 52. So I'm going to rewrite all the other parts. And the square root of 52, well, I know that I can do 4 times 13 to get 52. And that ends up being the highest perfect square. So when I simplify the square root of 4 times 13, I end up with 2 square root 13. There's one more step to simplifying this problem. We are going to leave the square root of 13 alone because we can't simplify it anymore. However, 10, 2, and 2, or negative 10, 2, and 2, they can all be simplified by dividing by 2. So my final answer, when I divide all three of those factors by, or those three numbers by 2, I get negative 5 plus or minus. 2 divided by 2 is just 1, so I don't really need the coefficient of 1 there. I get this as my solution. So I'm going to go ahead and box that in. That means that my 2 solutions are negative 5 plus the square root of 13 and negative 5 minus the square root of 13. But it just streamlines it if we keep that plus or minus symbol in there. So that's an example of one where it's going to end up with a square root in it still, and we have to just make sure it's simplified all the way. Moving on to our next example, we've got 5y squared equals y plus 4. Now, hopefully some alarm is like going off in your brain that this doesn't look right yet. And that would be correct. That's because we need to make sure that our quadratic is equal to 0 before we can solve. So that part is still the same as what we learned when we did solving by factoring. So in order to make my function equal to 0, we're going to subtract y and subtract 4 from both sides to kind of move those over and make sure it's equal to 0. Now I can do a, b, and c. If I picked a, b, and c before I moved those over, my answer would be totally jacked up. Like it would not be the same or correct. So a here is 5, b is -1, and c is -4. And now we're going to plug into the quadratic formula. So negative b would be -1. I'm going to go ahead and change that to plus because we don't want a negative. And then we've got the square root of b squared. So -1 squared minus 4 times a, which is 5, times c, which is -4, and it's all over 2a, so 2 times 5. So we start to simplify. We've got 1 plus or minus the square root. -1 squared, that's just 1, so that's pretty easy to simplify. And then -4 times 5 times, that simplifies to -4 times 5 times -4 would give us a positive 80. So if you need to pause, do stuff on your calculator before I continue, you can totally do that. So my discriminant is going to be 1 plus 80, which is 81, and it's all over 10. One awesome thing about this problem is that 81 is a perfect square, so thankfully it should be a little easier. My discriminant is positive, so that means I'm going to have 2 solutions again. And I should get 1 plus or minus 9, because the square root of 81 is 9, divided by 10. So when I split those up, since I have all numbers here, I can make my answer even more simplified. I would have 1 plus 9 over 10, which simplifies to 1. And then I would also have 1 minus 9 over 10. 1 minus 9 is -8 over 10, and that simplifies one more time to -4 fifths. -8 over 10 simplifies to -4 fifths. So my 2 solutions for this problem are 1 and -4 fifths. For example D, r squared plus 25. This is one that I know I would not be able to solve with factoring. Remember, we can do the difference of squares, but this is not the difference of squares. This is the sum of squares. And so it does not like factor really perfectly like the difference of squares does. So this is a good one to try the quadratic formula with because we know we can't factor it. Our a value is 1. The b value, remember, is in front of the x, which is not in this problem. So that means our b is 0. That means we really have r squared plus 0x plus 25. And then my c is 25. So we're going to plug that in to the quadratic formula. And we have -b, which we don't really need the negative sign because it's 0. And we've got plus or minus the square root of b squared minus 4 times A, which is 1, times C, which is 25. And it's all over 2 times 1. Okay, so now we go through our simplifying steps. So we've got 0 plus or minus the square root. And I'm going to simplify my discriminant now. So 0 squared, that's 0. And it's minus 4 times 1 times 25. If you have a calculator, you can type in the discriminant just like you see it, 0 squared minus 4 times 1 times 25, to make it a little faster. But I'm just making this assuming that no one has a calculator since we're all stuck at home. This would be minus 100. So we end up with 0 minus 100 is negative 100 as my discriminant. And that should seem kind of strange to you. So I want you to think back up here where we talked about the discriminant. If my discriminant is negative, that means I'm going to have 0 solutions. It's not going to cross the x-axis. So if you notice that your discriminant is negative, you could stop right there and you would say that you have no solution. So this is an example of when we would have no solution. Remember, that means there's no x-intercept. It does not cross the x-axis. The reason it's no solution is because we can't take the square root of a negative number. So since we ended up with negative 100 as our discriminant, square root of a negative number, can't talk and write at the same time. You know this about me. That means we stop right there and we just say there's no solution. So that's a possibility that you would get no solution there. The last example on this page, I would like for you to pause and try it, but I am going to go ahead and work it through now, especially since there's some bigger numbers. So you can pause and try it on your own, and then you can check it with mine when you're done. So here we have 24x squared minus 14x equals 6. I want to make sure I subtract that 6 over before I even start to make sure I'm equal to 0 first. Then my A is 24, B is negative 14, and C is negative 6. Don't forget those negative signs. And we plug into the quadratic formula. So I'm going to have negative B, negative 14, so change that to plus real quick, plus or minus the square root of negative 14 squared minus 4 times A, which is 24, times C, which is negative 6, all over 2 times 24. Now I can already tell you with these giant numbers, there's going to need to be a calculator involved at some point. When we simplify, we've got 14 plus or minus the square root, and I'm going to do my simplify here. So I've got negative 14 squared. Remember to use parentheses or do negative 14 times negative 14. You get 196. And then it's going to be minus negative 4 times 24 times negative 6, which is positive 576. Holy giant numbers. So then we want to add those together, and we get the square root of 772. It's a positive discriminant, so that means we should still be getting 2 solutions for this one. And then it's all over 48. Okay, so here we are going to simplify that radical, and it's going to be a little difficult. Stuff that I'm going to have you guys do on your own the numbers won't be this big, don't worry. The square root of 772. 772 splits into 4 and 193. And 4 is actually the largest perfect square that you can get out of 772. So when we simplify the square root of 772, we can take out that perfect square root 4, which is 2, and then we leave the square root of 193. Then looking at the 3 numbers that are remaining outside the square root, 14, 2, and 48. Those all 3 can be simplified by a common factor of 2. So the furthest we can simplify this solution is to divide each of those numbers by 2, which gives us 7 plus or minus 2 divided by 2 is 1, so we don't need that coefficient there, but it would be the square root of 193 all over 24. So those are your 2 solutions for this one. I'm actually going to rewrite that over here bigger because it looks a hot mess. So our solution is 7 plus or minus the square root of 193 all over 24. Remember, it still has 2 solutions because of that plus and minus. Like I said, y'all are going to have a quizzes practice assignment. It's a little longer because these are pretty challenging, and I want you to make sure you practice it as much as you can before you take your final quiz this week. As always, email me with any questions you have. We will do Zoom tutorials on Thursday. Also, I'm going to be posting a page that has some Khan Academy resources so you can see some more examples worked out. And